Okay, so a few years ago, maybe a couple of years ago, there was a lot of news about Arabian Sea or North Indian cyclones increasing in number. There is, of course, always stories about rapid intensification. Rapid intensification is easier to understand because the upper ocean is warming, hurricane potential is warming, hurricanes are moving slower, so you have a lot of energy and so on. The definition of rapid intensification, what jump you need in wind speeds per 24 hours and so on, are discussed elsewhere in this series. But this paper makes me think that maybe a trend in cyclones may be not so obvious. Maybe there is a decadal variability that is getting amplified. It's still a trend in some sense, but if there is an intrinsic decadal time scale, then that could still be very important to understand. Okay, so even if there is a trend, doesn't mean every year we'll have more cyclones. You will have out of 10 years you may have 6 years with more cyclones, and 4 other years will be normal or even below normal, but over time it begins to increase. So it's always complicated when you have short time series to conclude on trends. But this paper, which just came out, tries to summarize the tropical cyclones impacting the Western Arabian Sea and Oman. And when you look at only landfall cyclones, it can be very different than the actual cyclones that are born in the ocean, may die in the ocean. But Arabian Sea is typically very small compared to the Atlantic, for example, or the Pacific, where many more storms may be born and they may just wander off into the open ocean and die away. Landfall becomes important because they can do serious damage. The North Indian Ocean is also relatively small, so the cyclones typically don't get as strong as the hurricanes or the typhoons. Keeping all that in mind, tropical cyclones are major natural disasters that can cause significant damage and loss of life in coastal areas. Arabian Sea has experienced many such tropical cyclones, TCs, with varying degree of severity. These TCs are associated with heavy rainfall, flash floods, and make significant damage to infrastructure, society, and the environment. Range of factors influence cyclones in the Arabian Sea, including sea surface temperatures, ocean currents, eddy activity, the position of the monsoon jet axis, and the Indian Ocean dipole. Always throw it in. The frequency of these TCs has already increased due to rising sea surface temperatures and changes in wind patterns. Researchers have conducted extensive studies in the region to better understand tropical cyclones and their impacts, focusing on sea surface cooling, air-sea interactions, and the effects of climate change. By studying these TCs over several decades, trends and patterns can be identified, contributing to the development of more accurate forecasting models and early warning systems to better prepare for future events. This paper reviews the history, track patterns, biological and physical impacts, numerical modeling, and future trends of tropical cyclones in the Western Arabian Sea, with the aim of supporting policymakers in developing more effective strategies for mitigating the impacts of future TCs. So, it's a review article, meta-analysis. I'm not going to go into the details. I just want to use the figures to make a couple of points. So let's start with this one. Number of storms affected Oman. Number of storms that affected Oman per period, per month, for each category. So, long time series, 1980 to 98, 1900s, in the beginning, 20 to 39, 42, so 20-year periods are being looked at, and you can see that there is a jump. 60 to 79, already this period saw quite a big jump, almost 3 times or more compared to the previous decades, and then it took a dip in 1980 to 1999, and then it jumped up again in 2000 to 2020. What's happened so far in 2020s I will show in the next figure, because lot of news lots of news appeared in the media about how cyclones are increasing over the Arabian Sea, and then there have been few quiet years. As I said, the upward trend doesn't mean every decade or every year is going to be larger in numbers, but overall you will see a trend, right? So is there a trend, and if so, what is causing it, and then is there a decadal variability that is somehow amplified now? So there is a natural variability which is getting amplified by global warming and ocean warming, or the time period is getting modulated. But definitely there is a jump in number. Detection, reporting, all those things are always tricky, because if you go back in time all the way to the 1800s, how reliable are the data compared to the latter periods? So it's always complicated by something or the other. So number of storms by months, obviously we have a pre-monsoon period and a post-monsoon period. Then there is some argument that now closer to the pre-monsoon in June, numbers are increasing because of some wind impacts or reduced wind shear because of Arctic forcing and so on and so forth. So May sees a lot, and numbers, so this is per month each category, 0, 1, 2, 3, 4, 5. So those are the categories, and many are reported, but the category is unknown. And you can see that, no, let's make sure I don't screw this up, because I read it and suddenly I'm blanking out on that. That's not good. Yes, so I remembered it correctly. They are the cyclone categories depending on the wind speed. Less than 34 knots, it's a storm, not a cyclone. So in that sense, you can see that the categories of, they are recorded as cyclones, but their category cannot be determined from historical data. But even in the present state, you have unknown categories for whatever reason. But nonetheless, you just see the seasonal distribution. June here seems to peak just in terms of total storms, because this is categorized as a storm, but not by wind strengths, right? So to that extent, you have most of them appearing in June in terms of total cyclogenesis, let's say. We know that monsoon season is generally not a cyclone season. General idea is that it's because of the strong vertical shear associated with the monsoon circulation. So you end up with low pressure systems and monsoon depressions, which are cyclonic systems but not really cyclones, don't really grow into cyclones. There are very few that actually grew into a cyclone during the monsoon itself. And as monsoon begins to retreat, September and then October peaks, and you drop off again in November, December. We know that. But what is happening more recently, if you look at storms affecting the Arabian Peninsula by month here, May, June again re-emphasizes what we saw, but this one says September is only 4, but this is on specific category. So depends on how you classify them. October is peaking again. So monsoon lull, pre-monsoon, post-monsoon. But what I wanted to look at is again this jump in the number in the 2020s and then 2010s, and then there's been a drop so far. We are already into 2025, coming up into the pre-monsoon cyclone season. So if you added 2020s here, maybe there is a drop, but of course we are only halfway through the decade, so number can again jump up. So this is something to remember. My main point here is that maybe we need to look more carefully at natural variability in the number of cyclones at intra-annual or decadal timescales. So these are the pre-monsoon, post-monsoon, and tropical cyclones per season that affected Oman for 1981 to 1960, 1961 to 2021. Cyclone category colors represent so this is a pre-monsoon and this is a post-monsoon for the two periods. I won't spend too much time into it. There are some details there. Factors affecting the TC genesis in the Arabian Sea also we know pretty much. Cyclogenesis, there is a paper that I am involved in that argued that there is a jump in cyclogenesis in the southeastern Arabian Sea since about 97 maybe. This has to be looked at in terms of the numbers that we talked about, whether this jump is again part of the decadal variability, or if so, is decadal variability being amplified by ocean warming, global warming, and even marine heat waves are now invoked for rapid intensification and so on. But that's still consistent with increased heat content, cyclone potential. So local conditions, oceanic conditions, external climate patterns, and anthropogenic factors, SSTs, low vertical wind shear and high humidity, but cyclone potential is a little bit more than SSTs, as we have seen in other podcasts already. So high ocean heat content and warm core eddies. The detail there is that high SSTs don't always correspond to high ocean heat content, because wind stress curls can lift the thermocline or the 26-degree isotherm and actually reduce the hurricane potential. El Nino and IOD, La Nina and MJO phases affect cyclogenesis over the North Indian Ocean, and aerosol emissions are called up, black carbon and so on, for cyclogenesis impacts as well. And of course, global warming overall is in terms of wind changes and ocean heat content changes, SST changes, and so on. Maximum cooling and chlorophyll A changes due to tropical cyclones. They are comparing cooling amount and chlorophyll A in terms of anomalies. If there is a cooling, there is a chlorophyll response, but you can see that sometimes chlorophyll response is noted but not necessarily a cooling. But here is now typical GONU, TSO5A. So whatever data they could get, they have used Nilofer, Khyar and Maha, Shaheen. So basically we know that there is upper ocean response to cyclones, which pulls up water from several hundred meters sometimes based on its strength, which means nutrient supply. And if the cyclone has moved off and light is available, you will get chlorophyll blooms as well, and they can easily be detected in satellite images. And then the question of whether they help to reorganize SSTs and heat content as well because of their shading effect and so on and so forth. So just to conclude this very short, I use this paper just to raise a point about decadal variability. I already raised this with Roxy Matthew Cole, who does a lot of cyclone work. Projected changes of TCs over the Arabian Sea, how trustworthy they are. Well, if you think about it, depends on which period you look at. The next decade or two are dominated by internal variability and model uncertainties, but beyond that, scenario uncertainties begin to dominate. Models are not doing so well in this region in terms of the trends over India in the monsoon and land heating and so on. Aerosol impacts are always important, which may not be captured very well by the models and so on. But 18% rainfall rate increase, 5% cyclone intensity increase, westward expansion of cyclogenesis, 4-star TCs percentage of category more than, so whether overall numbers will increase or high intensity cyclones will increase. 30 to 64% frequency of TC, so that's a fairly large range as well. But it can be expected that SSTs will warm, ocean heat content will go up. But there are other related papers that look at the rapid warming on land over Western Asia, Middle East, Mediterranean, and show that winds have shifted. So how that affects the vertical shear distribution, heat content distribution, and cyclogenesis is also worth looking at. So I just wanted to use this, as I said, to just put a caveat that trend is not just a trend. It may be amplified natural variability at decadal time scales, multi-decadal time scales, because there is a decadal time scale in the monsoon as well, and we are emphasizing the trends a little too much without worrying about the regime shifts and the decadal variability as well. Just think about it. Okay.